Welcome back. Lecture 3. We're going to talk about electric circuits today. This is a big one. We're going to talk about many topics, all relating to electric circuits. So that's what we've been building up to so far with electric field, charges, Coulomb's law, which is the electrostatic force, electric potential energy, electric potential, which we said kind of translates to voltage. And so now we're going to build up the basic building blocks of electric circuits, which would be current, resistance, and voltage. So that's where we're going to start. And then we'll talk about a few other topics, and we'll end on RC circuits, R standing for resistance and C standing for capacitors, the thing that we ended off talking on about last lecture. It turns out that's an interesting arrangement to have in a circuit where you have a resistor and a capacitor on the same circuit. So now begins the middle section of this course, which focuses on electrical circuits. And so far, we have learned that we've learned about charges that are stationary, not moving, right? And that's complex in its own right. We know that these stationary charges have an associated electric field around them, which can interact with other charged particles. And we understand that there's energy associated with these electric field interactions, and that we can describe this electric potential energy per unit charge with a quantity called electric potential. And we denote that with a V. We noted that the difference in potential between 2 points is called the voltage, and we left off with the fact that that would play an important role in electrical circuits. And so to me, this is a very exciting part of our course, because in this and the next few lectures, we'll be learning about how all kinds of things around us work in our world. We use our phone every day, we might turn on our computer, right, and use a microwave, all these electrical, devices around us. And most people don't really bother to find out how it works. And so you guys will learn on the most fundamental physics level how a lot of these things work. So in the most fundamental sense, electrical circuits are ways to transport energy. Electrical circuits are a particularly cool way of doing this because they're solid state, which just means there's no moving parts, other than, of course, the tiny, tiny charges themselves that you can't really see. So to transport energy in your mechanics course, something was always moving, right? You're pushing a box, or you're, lifting it off the ground and getting it ready to drop, or, something, ball rolling down a ramp. There's all kinds of moving parts that would have associated energies, right? But with a circuit, you can transport an immense amount of energy without any motion, noise. It's just seamless. So it's very, very cool. And that's why it's so ubiquitous in our world. So it's actually such an efficient way to transport energy that our bodies actually even use electrical pathways to carry like vital signals from through your nervous system from one part of your body to another. But before we can appreciate all of these complexities and applications of advanced circuits and devices, we have to build up from the basics. So we'll start with current, then resistance, then the potential difference that causes charges to flow.